Hello, and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Throwback Thursday. This is Andrija Mohorovičić. I know, it's a mouthful. He was born in Croatia in 1857 to a blacksmith who made anchors, and he got a degree in mathematics and physics in 1875. So why is a geologist talking about a physicist? Well, in October of 1909, there was a large earthquake that hit Croatia near where he was living. And there were recently seismographs set up in the area, and he looked at them and he saw that the waves changed. He concluded that when seismic waves strike the boundary between different types of materials, they are reflected and refracted through the earth with different velocities. And he was the first to establish, based on this evidence, that a discontinuity existed that separated Earth's crust from its mantle. We now call this the Mohorovičić discontinuity, or the Moho, because most of us are not Croatian and we struggle with his name. So, Moho it is. He explained that a layered structure would explain the difference in velocities of seismic waves, as well as the difference in chemical composition of magmas. The mantle is made of ultramafic rock, while the crust has mafic and felsic rocks. He also estimated the thickness of the crust to be about 54 kilometers or 33 miles. Now, that may be true in some spots, but we now know that it isn't really consistent, and that the continental crust is much thicker than oceanic crust. But he led people to start thinking about that in the first place, to find that information. So typically our oceanic crust is actually between 7 and 10 kilometers thick, and the continental crust can get up to 70 kilometers thick, which is usually below mountains. Shocker, I know. He came up with an equation to calculate the velocity of seismic waves, developed a method for locating earthquake epicenters by constructing curves for travel times, and even developed a new type of seismograph, though it never got made because he lacked the funding to do so. Curse the lack of funding and the fact that it keeps happening to us. Finally, one of his biggest contributions was actually working alongside architects and building contractors to make earthquake-resistant building designs so that buildings don't fall over. In fact, here in Salt Lake, they're actually doing this with several buildings, including the Church of Jesus Christ of Latter-day Saints temple in Salt Lake. They're putting these buildings, these older buildings, on these rubber shock absorbers and giving them the steel frames they need to allow them the flexibility to move should the earth move, and that way these historic buildings don't crumble should the big one hit. All in all, Mohorovičić did a lot of amazing things that helped lead to a branch of geology known as seismology. Now, personally, there's a little too much math and physics involved in seismology for me to ever enjoy it or be able to handle that kind of brain power. But earthquakes are still cool, so kudos to those who do have the will and power to do that, because that's never going to be me. And I hope you guys tune in tomorrow to learn about a giant ground sloth. So I will fossilize you later.